This is Miss Tawanda. Hope you all are doing well. I am sending you this video because this past week of school we had a lot of technical issues with Zoom and you guys could not hear me. And so what I wanted to do was create this video to make up for the lecture that we tried to have. And so this will allow me to communicate some of the concepts that I wanted to communicate this week. So you should see a PowerPoint slide that says weather forecasting continued. So I'm going to begin to move through this and take you through the lecture. So we've already talked about air pressure and barometers and how to read barometers. We've talked about weather coding and how with weather forecasting symbols are used because there's a lot of data involved. And so you guys had an assignment to make a station model card, which I look forward to reviewing soon. Then on Tuesday, we talked about air masses and fronts. I know then we also had some technical difficulties, so I want to just briefly review this just to make sure you guys got everything. So basically an air mass is a large body of air, that has the same temperature and humidity throughout. So if you look at this map of North America, you see different air masses located across the region. Obviously, the cooler and colder air masses are going to be further north, and then the warmer and hotter air masses are going to be south. Also notice that air masses that are dry are over the land, and then air masses that have moisture are over the water. And what happens with these air masses move and they begin to interact and collide with each other. And when these collisions happen, they form what's called a front. So fronts are nicknamed the weather makers because it's with fronts that we get a lot of our weather systems that bring precipitation, whether rain or snow or sleet or hail as well. Okay. So there's 4 types of weather fronts. And I showed a video in class that discussed the cold and warm, but I want to review those again. So we have what's called a cold front. And so remember with air, warm air rises, cold air sinks. So it's similar to what we talked about in the oceans unit when we talked about warmer water rising and colder water sinking. Same concept that applies to air as well. So we have a cold air mass that's approaching a warm air mass. All of them are moving, but the cold air is able to quickly catch up with the warm air mass. And what happens is because cold air is more dense or denser and it sinks, it goes under the warm air mass and pushes it up. That interaction creates a cold front. And with cold fronts, we tend to have our more intense weather, whether it's thunderstorms or snowstorms. Then we have a warm front, which is the reverse of the cold front. So this time we have the warm air approaching the cold air. What happens is the warm air is still going to go above the cooler air because cooler is denser, but it's not as aggressive as a movement. So it's more of like an incline. The warm is going gradually over the cold air mass. And so again, this has precipitation with it, but it's not going to be as intense weather conditions as a cold front. Then we have our stationary front. So remember we talked about the word stationary, and what does that mean? Basically to be still. So you have a warm air mass and a cold air mass that have met, but nobody's really pushing anybody out of the way, so they're kind of at a standstill. And what happens with this type of front is you have rain, but you tend to have rain for several days. Okay, it's kind of like just a lockdown. Nobody's really pushing or progressing. Okay, eventually one will, but at that time they're stalled. Then we have an occluded front. This is where we have a warm air mass and a cooler air mass that are just kind of off to the side, hanging out, chilling. And then this colder air mass decides to come in and interrupt things. Basically, it approaches and it actually kind of almost picks up both of those air masses and lifts it up. And that place where they all kind of interact and join is where you'll have precipitation. Okay. So with our fronts, we have symbols as we discussed. So the cold front has triangles on one side of the line. The warm front has half circles on one side of the line. The occluded is triangles and half circles alternating on one side of the line. And then stationary is triangles and half circles alternating, but on opposite sides of the line. And if you're in a situation where you can see it in color, the cold front will be blue, warm front red, occluded will be that lavenderish light purple deal, and then you'll see the blue and red in stationary. So just to recap, with fronts, when we're dealing with the air masses, remember that warm rises, cold sinks. Warm is less dense, cold is denser. So the cold is going to push that warm air up. Fronts bring rainy weather. Fronts tend to move from west to east, north to south, or south to north. And then again, cold fronts bring about the more intense weather conditions. So we watched some videos in class. So this is just a picture of how an occluded front would look. So again, we have the warm and cool kind of hanging out and the cold's coming in. And then where they all meet is where you see the precipitation. Okay. Here's an illustration of our stationary front. Again, it's kind of a standoff. Nobody's really pushing anybody or overpowering anybody, and they just kind of hang out and chill for several days, bringing rain. Okay. So meteorologists at the National Weather Station receive weather and data from thousands of reporting stations around the world. So even within the US, you have all these different weather stations that gather data and they communicate with each other about what their findings are so that they can work together to more effectively forecast the weather. So sometimes if we're looking at a region like the US and you have these weather stations reporting their data to one another, you see all these ranges of temperatures across the nation, and we'll see pressures in a minute, but basically you begin to kind of see these patterns of temperatures forming across the landscape. So for example, if you look at the map on the right, you see 40 degrees kind of through Nevada, California, Arizona, Texas, going up through Arkansas, up to Illinois, to the Great Lakes, and even beyond, all the way up to Maine. Then you also see another example, 80 degrees in Texas, goes up through Louisiana, Alabama, Mississippi, Georgia, up to North Carolina. So basically you're seeing these patterns of temperatures across the land. And so what the meteorologists will do is they'll draw these lines on the map connecting all these temperatures that are the same. And it helps them better understand how weather is occurring across the landscape and how patterns are moving across the landscape. These lines are what we call isotherms. Therm means temperature. ISO means equal, so equal temperatures. So everything that's equal gets connected in the line. So it's kind of like a dot to dot type thing. Okay, so again, this gives meteorologists a visual of how patterns, weather patterns are looking across a particular region. We do the same thing with air pressure. So again, if you look at the map on the right, you see, for example, 1020, 1020, up above Montana, going through Idaho, Nevada, California, Arizona, New Mexico, and then it actually loops back around to Nebraska and up through like North and South Dakota, making this circle. You also see, let's see another example, 1016. So you have 1016 up by, I guess that's Minnesota or wherever, kind of up north by the Great Lakes, coming through the Midwest, Kansas, Oklahoma, Texas, looping around to Louisiana and Florida. Okay, it even actually goes around to, I guess that's Maryland, and up along the New England area up to Maine. Okay, so again, this is a pattern of air pressure across the region that can help meteorologists understand how weather is moving across the landscape. So when they get these maps, they draw lines connecting the dots of air pressures that are similar. And these lines are called isobars. So remember, with bar, we had millibar, which is the unit or a common unit for air pressure. Iso means equal, so equal air pressures. Okay? So this is a more real life map of isobars, isotherms that a meteorologist would create and use. So it looks pretty involved and complicated, but this is the idea to kind of show how weather patterns are moving in a particular area. Activity sheet 8 deals with isobars and isotherms, but I didn't assign it because I want to do it in class just to make sure you guys understand it, okay? So hold off on doing that particular activity sheet unless you just want to give it a shot, but it hasn't been assigned. So now we're going to look at clouds. This will probably be reviewed for a lot of you guys, but I just want to go back over it. So there's three main types of clouds. There's cirrus clouds, cumulus clouds, and stratus clouds. Cirrus clouds are going to be clouds that are in the higher level or a higher layer of the atmosphere. They're very thin, linear looking, wispy looking clouds. Cumulus clouds look like the cotton balls. They're puffy and full in the middle layer of the atmosphere. And then stratus is going to be our lower level clouds, just more spread out, sheet-like cloud appearance. Now, there's other variations of this depending on if the cloud maybe has some similarities between two types, or if it's a little bit higher or a little bit lower than what it would normally be. Then we have something over to the right called a cumulonimbus, which we'll talk about more in a moment, but it's just a larger version of the cumulus cloud. How do clouds form? So if you remember back from the water cycle, when we talked about that in the oceans unit, water evaporates, it rises in the atmosphere. As we go up higher in the atmosphere, the temperatures get cooler, and then what happens? That water vapor condenses into a liquid, eventually will come back to the ground as some sort of precipitation, and then the cycle repeats. So that's the water cycle. So in the midst of this cycle, when we have our water vapor up in the higher atmosphere and the colder temperatures, some of that water vapor will condense like normal, but what happens is it'll condense on something called a nuclei, Nuclei. You see that in the slide here on the screen. A nuclei is basically any type of particle that water vapor can condense on. It could be dust, smoke, even some sort of chemical in the atmosphere, maybe pollution of some sort, just particles being up there. The water vapor will condense on that nuclei and then form a cloud droplet. And as these droplets collect, then clouds are formed. So again, just reiterating some information about the clouds. We have our three types. Typically with cirrus and cumulus, you'll have nicer weather. Okay? But with stratus, you'll have light rain. And then we have that term nimbus. Nimbus basically means some type of storm. Okay? So cumulonimbus is going to bring a thunderstorm. Nimbostratus, yeah, we know stratus is rain, but this time it's going to be heavier rain because of that type of cloud it is. So if we go back to that picture we were looking at, you see the cumulonimbus cloud, how it's larger, it's still puffy, And this illustration really doesn't reflect it the best, because with those type of clouds, they're going to be grayish clouds because they're carrying a lot of precipitation. Okay, so it's not going to be white and clear like a cumulus cloud would be. Another type of cloud that you would maybe think of as being a cloud is fog. Okay, so fog is basically a cloud that's on the surface of the ground. So we have that water vapor that's condensed on particles that are just at the lower level layer near the ground, and it produces a cloud, and that's what fog is. Okay. So I think that's it for what I wanted to go over this week. So I've posted some assignments that you probably have already seen. I posted the last major project you'll have for this unit, which is making a barometer. That is due Thursday of next week. I also assigned activity sheet 9, which is creating a cloud at home. So there's a simple activity involved with that at home that'll allow you to answer the questions along with an additional YouTube video. I think the sheet says to use a match, but the video I provided, they used aerosol spray. You could just use the spray and that'll work the same. So don't be thrown off by that. And I think I included that in the instructions for the assignment, okay? Then I also assigned activity sheet 10, which is just classifying the cloud types we've talked about. So that should be pretty simple. So again, once you've watched this video, make sure you pull up your assignments, look at the additional YouTube videos that you're supposed to look at, when you're supposed to look at them, and you should be able to complete all of your assignments at this point. So I hope this was clear and helpful. If you need anything, please reach out, and hopefully the technical issues will not be there next week. So anyway, thanks a lot, you guys, and see you soon. Bye-bye.